So when it comes to using a class like that, here's how you would do that. So this is the file that contains the main function. And so first thing we do is we include the IOStream standard library to provide us with output facilities. We include our point header that contains the point declarations, and then we define our main function. And as you know, of course, each C and C++ program has to have exactly one function called main. There are two ways and only two ways to declare it. It must return an int, and there are two versions of it. One doesn't take any arguments, the other one takes arguments to deal a particular way, kind of arguments to actually deal with command line arguments. Case in point, however, main must return an int. And if you see, especially in older books that deal with Microsoft's compilers, and Microsoft's C++ or C compiler for that matter really has only been the only compiler ever to accept a void return type. But void main never has been part of the C and C++ standard, and you can safely ignore any book that in their Hello World program shows you a void main function, because these authors have never read the C or C++ standards for that matter, and are relatively clueless, so you should not trust that book at all. So, and the reason why we return an int is to let the operating system know whether a program has succeeded or failed. And as you can see down here with the 0, usually a return value of 0 means that the program has executed correctly. And any non-zero return, there's a slight difference between positive or negative return types, return values. But any non-zero return type will typically indicate to the operating system, and possibly any scripts that control the execution of an overall larger system, that something has gone wrong. So then we actually allocate a point object on the stack that happens right here. This happens at compile time, and that's why the declaration is important, because the declaration contains enough information so that the compiler can actually do that and knows how much memory to allocate at compile time statically on the stack. Also, remember, or if you haven't taken 301 or 302 yet in terms of operating systems and computer organization, that what on the compiler side in C and C++ we call the stack is not identical to the call stack that we use to specify, to call subroutines and return from them. So stack here really means, and it is a stack, yes. So the compiler can at compile time follow through with all the operations, and it is a stack-based operation, but just basically realize then on the basis of the maximum extent of the stack on how much memory to actually allocate inside the executable to be part of that stack, and guarantee that it never runs out of that memory. So, and then of course, however, we also have to have ways to dynamically allocate memory on what we call the heap at runtime, because not all information to us is available in terms of what data we want to process and how much of it at compile time. So we have to have a way at runtime to request more memory from the operating system, and that memory is organized in what we'll call the heap, and in particularly in C++, this happens here with operator new. This is an operating system call in disguise. It actually calls the malloc on Unix systems, at least. It'll call the malloc system call, and then other operating systems it will call other system calls, but it's a relatively expensive operation. And what we will get is an object on the heap that we'll have to refer to, because we don't otherwise know exactly where it is, via a pointer. So we're going to get back a pointer rather than the object itself. So it's a pointer to the object that lives on the heap. And then we can call, of course, methods here. Again, remember here there is no using namespace std, so that's why I use the prefix std for our stream output, standard character output stream. And then we can call, of course, the distance member function for our first object that lives on the stack using the classic dot notation, where the object comes first and then the dot and then the target, the member function. And we can't do that for the pointer. We have to dereference the pointer first and then we could have called that. And since the syntax for this is relatively awkward, ever since even C had, of course, what they called syntactic sugar, and had a shortcut notation, so that when you do a member function call through a pointer, you have this arrow notation here that kind of drives home the point that point2 actually is a pointer. And that's then basically it, and this is really how our basic first class actually works.